Hello everybody, welcome back to another video. We're back with another integration shortcut. So basically we call this integration shortcut specifically DI method. Okay, so in this DI method we have this first function, which is polynomial function. So basically this is going to be our first function. Alright, and then so this is going to be our first function, the first function. And then we have also this f of x function. This is my second function. So basically this f of x function could be trigonometric function, or it could be also an exponential function in order for us to implement this formula. So basically, according to this DI method, so we're going to differentiate the first function, okay, and we're going to integrate the second function. So basically we're going to keep differentiating the first function until we get 0. Alright, so let me show you what it is. So let's get started. So we have this problem, integral x squared times sine 2x dx. So basically this is my first function, and then this is my second function. So basically in the DI method, what we're going to do is, so I'm going to put d right here, I'm going to put I right here, and I'm going to put my first function, which is x squared. So I'm going to keep differentiating this until we get 0. So we get 2x, then we get 2, then we get 0. Okay? And then my second function is sine of 2x. Okay? So basically, we're not going to put this. So we're going to put the integral of sine of 2x, okay? So that's going to be equal to negative cosine of 2x divided by 2 when you integrate that. And when you integrate this negative cosine 2x divided by 2, you get negative sine of 2x divided by 4. And when you integrate this, you get positive cosine of 2x divided by 8. And we're just going to leave it blank because the last derivative is 0. And then right after that, what we're going to do is we're going to do cross multiplication. So I'm going to cross multiply right after this. So we're going to multiply these two, multiply these two. But when we multiply that, the first is going to be plus sign, second is going to be negative, plus, and minus. Okay, so let's do it. So basically this original integral is going to be equal to x squared times sine of 2x dx is going to be equal to, so negative x squared times cosine of 2x divided by 2. Then we're going to put minus, then we're going to multiply 2x times negative sine of 2x divided by 4. Then the next one is plus, then it's going to be 2 times cosine of 2x over 8 and plus c. So of course we have to put this expression in the simplest form. We need to simplify it as much as we can. So basically this is going to be equal to negative x squared times cosine of 2x divided by 2. And for this one we have negative and times negative, it's going to become positive. And also I can simplify these two. So basically we get x times sine of 2x divided by 2. Then I can divide this 8 by 2, so 8 by 2, so we get 4, so it's going to be equal to plus cosine of 2x divided by 4 and plus c. So that's my final answer. Okay, so first we need to determine what's my first function. So always the polynomial function is always the first function, and other trigonometric or the exponential function is going to be my second function. Then we're going to keep differentiating the first function until we get 0. Then we're going to keep integrating the second function. Then we're going to multiply the first derivative by the first integral times second derivative by the second integral times the third derivative by the third integral, and so on. And for the first one we're going to use the plus sign, we're going to use negative sign, we're going to use plus sign and negative sign. So that's the order. Alright, so when we put them together and when we simplify the expression as much as we can, we're going to end up with this answer. Okay, Alright, so I'm gonna erase this solution and we're gonna move on to the second problem. Okay, so let's move on to the second problem. Again, when you look at the second problem, as you may see that we have this first function as, you know, the polynomial function, and we got the second function as exponential function. So again, d and I, and my first function is x to the fourth. Let's find the derivative of it. We get 4x cubed. Differentiate, you get 12x squared. Differentiate, you get 24x. Differentiate, you get 24. Differentiate, you get 0. Then I'm going to put the integral of e to the power of x. Then same thing, because we know that the integral of e to the power of x is just itself. So we're going to keep doing this until here, and I'm going to leave it blank because the last derivative is 0. Then we're going to always start off with plus sign, minus sign, plus sign, minus sign, plus sign, and minus sign. So let's multiply these two, 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 and multiply these two. And we don't forget to put these signs in between the terms, okay? So basically that's going to be equal to, so that integral, original integral, is going to be equal to x to the fourth times e to the power of x dx is going to be equal to e to the power of x times x to the fourth plus 4x cubed, actually, yes, 4x cubed times, actually it's not going to be 4x, correction, it has to be negative. So 4x cubed times e to the power of x, the next sign is plus, so it's going to be 12x squared times e to the power of x, the next sign is going to be negative, and 24x times e to the power of x, the next sign will be positive, which is 24 times e to the power of x, and plus c. Also, if I put this expression in a in a nicer way, we get, if I factor out of e to the power of x, we get x to the fourth minus 4x cubed plus 12x squared minus 24x plus 24 and plus c. So that's the answer of the second integral. Okay. Alright, so let's move on to the third problem. So before we move on to the third problem, let me wipe off the board. Alright, here we go. So the third problem. In this third problem, we have again the polynomial function as the first function, and then we have this trigonometric function as the second function. Alright, let's continue. So again, we're going to apply the DI method. Okay, so we're going to get x right here. So when I differentiate it, I'm going to get 1. When I differentiate it, I'm going to get 0. Again, this is going to be plus, this is going to be minus, this is going to be plus. Then the integral of cosine 3x is going to be equal to positive sine 3x divided by 3. So when you keep integrating that, you're going to get a negative cosine 3x divided by 9. And we're going to stop here because the last derivative is 0. Then the original integral is going to be equal to x to the fourth times, I'm sorry, not, so the original integral is going to be equal to, so x times cosine 3x dx is going to be equal to x times sine of 3x divided by 3. And then the next sign is negative, and 1 times negative cosine of 3x divided by 9 and plus c. So let's put it in a nicer way. We get x times sine of 3x divided by 3, and plus we get cosine of 3x divided by 9 and plus c. So that's the answer of this last integral. Alright guys, in this video we talked about one of the very handy and helpful integration shortcut, which we call it a DI method. In this DI method, we have a product of the polynomial function and a function, and that function could be a trigonometric function or exponential function. So if we can apply this method, the first function has to be polynomial function, the second function has to be either a trigonometric function or exponential function. Thanks so much for watching this video. Hopefully you enjoyed this. If you enjoyed this, please do not forget to subscribe, share, comment, and like. Thanks so much. Bye.